Okay, hello everyone. My name is Mihai Budiu. I'm a researcher at VMware Research, and it's my pleasure to introduce the speaker in this session. His name is Kaarthik Alagappan from University of Central Florida, who together with an international team has done this work on SuperP4. It's essentially a P4 compiler that also knows how to interpret preprocessor directives and can compile simultaneously multiple programs. Thank you.
Thank you, Mihai. So hello, everyone. So this is a project called SuperP4. It's a preprocessor-aware syntax and analyzer for the P4 programs. So let's get started. So right now, P4 developers, they use the preprocessor directives to make a single program highly configurable. So rather than having to rewrite a P4 program with different features in it so that there's multiple versions of it, right now they have a single program, and they use the preprocessor directives to conditionally include features or states or multiple things, and they control it using the build system. So for example, if you look at the first image, we see that the developer is using the preprocessor flag call with IPv6 to conditionally include transition statements inside a state. In the second image, we can see that they use the same preprocessor flag to conditionally include multiple states. So they can conditionally include states, transition statements, new variables, all those things. And the third image, it's a similar statement. This example is taken from Ono Satellites' Fabric program. And in addition to the with IPv6, there are 10 more preprocessor directives. So with 11 preprocessor directives or 11 features in this case, there are more than 2,000 possible configurations that need to be tested, which brings us to the next point that current existing verification tools like P4V and Vera, they've only worked with a single configuration of a P4 program. So for something like Fabric, it has to be compiled with different features enabled. And for each single feature, they have to run it individually. And as you can expect, it's very expensive because as we saw before for the Fabric program, it's 2,000 different configurations. And running it 2,000 times can be very expensive. So right now, the developers, they only check for a small set of configurations, which can lead to potentially missed bugs that can arise from enabling different configurations that they did not test for. For example, if you look at the code block on the left side, we can see that the developer is using two preprocessor flags to enable two control blocks. So if feature one is enabled, the control feat one's control block is invoked, where we set the UDP's validity bit to be 0 or invalid in this case. And if feature two is enabled, we invoke the port counter feat control block, where we set the same UDP's validity bit to 1, so to be valid. If both the features are enabled at the same compilation, then we have conflicting statements. And at the end, the UDP validity bit will be set to 1. The developer might have intended this to be the use case, or it could have been a bug that they missed because they didn't check both those configurations at the same time. And that is what we want to avoid in the future. So we want to warn the developers if there are any conflicting statements between configurations. And that's where SuperP4 comes in. So SuperP4, it's an extended version of an existing tool called SuperC. And SuperC does a preprocessor-aware parsing for C programs. So we have extended that to support for P4 programs. And SuperP4, it takes in a whole P4 program with the preprocessor in it, it parses it, and it produces a preprocessor-aware AST that we can use to perform analysis with the configuration context. So the image here is a simple P4 program. We have a variable called validity, and we set it to 0. And during compilation, if the valid macro is enabled, we have a new statement that's retained that sets the validity value to be 1. So the regular parsers, they first do the compilation. And if the macro variable was enabled, they retain the statement, else the statement is removed. But SuperP4, it retains it either ways. And on the right-hand side, we have a logical structure of the AST that will be produced by SuperP4. So we see that we have the validity equal to 0 statement in it. And after that, we have something called a conditional node that says whatever inside the conditional node has to meet the conditional node's Boolean variable. So here, the conditional node would be that if valid is equal to true, or if the valid configuration is enabled, we will retain the validity equal to 1. And that's how SuperP4's AST has the preprocessor context information in it. And SuperP4's goal is to build an analyzer that will perform class configuration analysis, and it will warn the developer of potential conflicts that might need attention to. And the main types of checking that we are planning to do with SuperP4 is to check if there are If the same value is modified under multiple configurations, like the example that we saw before, and if there are any type errors between and within configurations. So let's say if X is defined to be an integer, but it's used as a string in another configuration, that's a potential type error conflict between two configurations that we'll want to look at. And we also want to check if there are incompatible configurations between two different features. Those are the things that we are aiming to warn the user of. So at the moment, SuperP4 is able to parse P4 programs with the preprocessor context in it. And currently we're working towards building a type checker and a calligraph analyzer that takes in the preprocessor context where each node is tagged with the preprocessor information in it. And we can perform analysis like data flow analysis to check if those conditions are meeting or if they're failing. And ideally, SuperP4 will be used to analyze all the P4 programs with all configurations at once without having to do it individually. Thank you.
Yeah, this is really interesting. What are the plans are you for the future of the tool? Do you want to contribute it to the open source compiler?
Yes, so right now we're still working on expanding it to support all configurations. And once all configurations are supported and we have run the test case, yes, we do plan to make it open source.
Another question I have, it seems like this is in general a very difficult problem because the fragments between if defs might not be syntactical complete constructs.
Yes, that is very true. So that's one of the things that we plan to warn the user developers of. So we plan to do data analysis and check if there are type errors between different constructs. And if anything does not match with each other, we will warn the developer. Like there's something that you may need to look at.
I mean, the C preprocessor could generate, half of an identifier from one macro and half of an identifier from another macro. So do you support the use case?
So SuperP4 will parse it and it'll show an error if that's the case, if it's broken between. So if the grammar itself is broken, SuperP4 will throw an error at that stage.
Another thing which seems complicated is the fact that a program composed of such multiple fragments will actually not respect the P4 grammar. Like you could have two sets of definitions for one block, for example, with only one which is used in practice at any one time.
So yes, yeah, that's in the future roadmap for us to do the data analysis. So data flow analysis. So if we notice that the definitions change between different configurations, we will again warn the user saying that there's incompatible uses of that.
Well, one case I was wondering about is whether you actually have two definitions which are compatible. They have the same type, but they have different bodies. So yeah. Like, so that's a legal.
Yeah. So again, yeah, we will warn off that. So if there are multiple definitions of the same variable, we will again warn off that, warn the developer of it.
But in a practice, you expect only one to be included because the two macros are never enabled at the same time.
Yes. Yeah, so if there are conflicting definitions or if there are multiple definitions between configurations, with the data flow analysis, we will see that it's being defined under a different configuration. And we will tell the developer saying that if these two are enabled at the same time, you can expect a conflict right there.
And the other tool that you said you modified, SuperC, is that also available?
Yeah, SuperC is open source, yes.
What is the licensing for SuperC?
I'm not very aware of that. My professor, Dr. Paul Gazzillo, he did SuperC. So I'm not fully aware of the licensing of the SuperC.
Because I suspect if you open source this SuperP4 compiler, it will have similar licensing as SuperC.
Yes. That's true. Yes, I fully had to look into it.
And my final question is whether you are using any of the code in the open source repository, or this is a tool written from scratch? From the P4
it's not fully
open
written
source.
from scratch. Yeah, so we use SuperC's baseline program, and we extended the grammar to support P4. Then we're building on top of it to do all the analysis.
But in the P4 grammar, did you reuse the open source grammar, or you had to rewrite another one?
I adapted the open source one from the P4 compiler, the P4C. I adapted it to fit with SuperC's grammar.
That's great, because this is what open source is about, really sharing the results. Thank you.
Exactly.
I'm looking forward to your contribution.
Thank you.